Today's seminar is going to focus on the Pythagorean theorem, and our goal or I can statements for this lesson are going to be: I can prove a triangle is right using the Pythagorean theorem. I can find the length of the hypotenuse of a right triangle using the Pythagorean theorem. I can find the length of a leg of a right triangle using the Pythagorean theorem. And I can find the distance between 2 points on a coordinate plane using the Pythagorean theorem. So at this time, if you could pause the video and go ahead and write this title in your notebook as well as the I can statements for this lesson. Okay. So we're going to have two foldables for this lesson. The first one that we'll look at deals with the Pythagorean theorem as well as the converse of the Pythagorean theorem. And the second one will deal with finding the distance between 2 points on a coordinate plane using the Pythagorean theorem. So we'll start with the yellow one first here, and we're going to be working under the Pythagorean theorem flap. Zoom in here a bit. Alright, so the Pythagorean theorem. Have an example here, a little bit of a definition as well, so that we can understand what we're working with and why we're working with it. Alright, so it says here, the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse, so that's going to be an important word here, so hypotenuse, is equal to the sum of the square of the length of the legs. Legs are also going to be important here, so I'm going to underline both of those. So what is this saying? Let's figure that out using this example that we have here. So in this case, the equation that's used for the Pythagorean theorem is a squared plus b squared equals c squared. And both a and b always represent the legs of the right triangle, and c always represents the hypotenuse. Now the legs are always going to be the two shorter sides of your right triangle. I should mention that the Pythagorean theorem only deals with right triangles, so any other type of triangle you wouldn't be able to apply this rule to. So if we're looking at the legs in this triangle in our example here, we have 3 as a side length over here. This bottom one would also be a leg, and the length of that is 4. And the longest side of our right triangle is always our hypotenuse. And our hypotenuse here is a length of 5. So 3, 4, and 5. Now let's kind of break down here what this equation does. So what it says is the square of A, we'll say 3 is A, plus the square of B, so squaring that number and literally making a square out of that side, is equal to the size or the area of C squared. So we can see that visually there. So in this leg, we have 9 squares. In this leg, we have 16 squares. 4 by 4 is 16. 4 times 4 is 16. And in the big one, we have 25 squares. So what the theorem is saying is that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. 9 plus 16 is 25. So the area of these two squares equals the area of this big square. Let's look at this algebraically as well. So we said 3 we were going to use as a, so we will have 3 squared. And then the second one plus our other leg in this case would be 4. So 4 squared is equal to c squared, and c is 5, so 5 squared. Now if we actually square these, we can see that these two will be equal to one another algebraically and visually. So 3 squared is 3 times 3, so that's 9. And then plus 4 squared is 16, or 4 times 4. And that is equal to 5 squared, which is 5 times 5, or 25. 9 plus 16 is 25, which means 25 is equal to 25. So in this case, this works out. A triangle with sides 3, 4, and 5 would satisfy the Pythagorean theorem. And this is actually a special case which we call a Pythagorean triple. And a Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. And they mean positive integers 3, 4, 5. And they're positive because lengths are always positive. We would never have a negative length. So there's cases where there aren't Pythagorean triples, and that just means that you get an answer that is not an integer, it's not a whole number, basically. So let's take a look at a couple examples here then. And what it wants us to do is identify the unknown side as a leg or hypotenuse, solve for x, round to the nearest tenth if necessary, and tell whether it is a Pythagorean triple. So a couple things to do here. We'll keep using blue for the hypotenuse. So in this first case of letter A here, this is actually the longest side of the triangle. So the unknown side would be our hypotenuse, which means we're going to be solving for c squared. So I'm going to go ahead and write down the Pythagorean theorem then, because we're going to need to know that in order to solve this and fill in the numbers necessary. So a squared plus b squared equals c squared. Now for a and b, since we know both of the legs, which are 24 and 7 here, I'm just going to circle those in red so that we know that there are legs. When we plug these into, or when we substitute them into the equation here for the Pythagorean theorem, it doesn't matter where you put them because a and b both represent legs. So I could say 24 squared plus 7 squared equals c squared, or I could say 7 squared plus 24 squared equals c squared. It'll give me the same thing. So let's go ahead and fill in the numbers that we know then. So we have 2 legs, so we're going to have 24 squared plus 7 squared, and that's going to be equal to c squared. So c squared is our unknown at this time. We need to figure out what that is. So first and foremost, we'll need to square both 24 and 7. You have a perfect squares list that would come in handy at this time, or if you want to use a calculator to do it, that's fine. So 24 squared is 576 plus 7 squared, I know that one, that's 49. And that is equal to c squared. And yes, you should be showing all of this work when you do this. I'm going to expect that. So if we add these together, 576 plus 24, or I'm sorry, 49, that's 625. So we have 625 being equal to c squared. We have to get c by itself, but at this point it is squared. So the way to undo a square is to take the square root. Those are inverse operations of each other. We talked about that way back in the beginning when we did order of operations, I believe. So if I take the square root of both sides, remember this does not mean division. It's taking the square root. So we're finding the number that we multiplied by itself to get 625. So if we take the square root of a square, that just gives us back our original number. So that's c. And if I take the square root of 625, I get 25. So 25 equals C. And since this turned out to be 3 positive whole numbers, that means that this is a Pythagorean triple. And to identify that, I'm just going to say over here in the margin, I'm going to say yes, it is a PT, a Pythagorean triple, which we talked about up here. All right, let's do another example then here in letter B. So looking at this, I'm seeing that I am going to have to identify the hypotenuse in this case. So these are my legs, then I know 7 and 5 are my legs, and this x would be my hypotenuse. So then if I write a squared plus b squared equals c squared, we can figure out what c squared is since that's our hypotenuse. So 7 and 5 will be our legs. It doesn't matter where they go in place of a or b because a and b both represent legs. So 7 squared plus 5 squared is equal to c squared. 7 squared is 49. 5 squared is 25. And that's going to be equal to c squared. And then if we add those up, we get 74. And that's going to be equal to c squared. Here's where our square root comes in then in order to get c by itself. Take the square root of both sides and we'll say is equal to c. Square root of 74. 74 isn't a perfect square, so in this case we'll have to round to the nearest tenth. So if I take the square root of 74 on my calculator, I get 8.6. So in this case, if we're looking at the idea of the Pythagorean triple, this one is not because we did not get a whole number for c. So that means no, it is not a Pythagorean triple. What I'd like you to do now is try C and D. These ones you'll have to solve for a leg, so there'll be some subtraction involved. I'll actually do one with you prior to you trying the last one. So let's look at letter C then. So in this case, our longest side is 20, so we know what the hypotenuse is. 10 is going to be a leg, and this x is going to be a leg. So we're going to have to solve for either a or b in this case. All right, let's go ahead and say that we're solving for a leg here. So write down our equation, which is a squared. Get some more room here. A squared plus b squared equals c squared. Now, where we put the 10 in the a or the b, it doesn't matter because we're solving for one of the legs either way. So I'm just going to keep it, I'm just going to put 10 in for a. So 10 squared. We don't know this leg, so I'm just going to keep b squared in here. And this is going to help us solve what this x is here. And that's going to be equal to 20 squared in this case, because we know what the hypotenuse is. So if we go ahead and rewrite everything by squaring these, so 100 plus b squared equals, I believe 20 squared is 400. It is. So this is 400. Now basically we have a two-step equation here. So this two-step equation stuff is coming back that we've looked at earlier in the year. So that means I'm trying to get b by itself so I know what the length of this leg is. So I'm going to first have to subtract 100 from both sides. That means this 100 is gone on the left side. I have b squared equal to 300. Now in order to get b by itself, I'm going to have to take the square root of both sides like we did in our previous problems. 300 is not a perfect square, so I'll have b here because a square root undoes a square. And if we take the calculator, take the square root of 300, we get 17.3 is our approximation for our other leg. And we can kind of check and make sure that our answer makes sense because my two legs should be smaller than my hypotenuse. So 10 is smaller than 20 and 17.3 is smaller than 20. That means that that is a correct answer to this. And if we think back to the idea of Pythagorean triples, this is not a positive integer. Well, it is, but it's not just a number by itself like a 3, 4, 5 or 24, 7, 25. So no, this is not a Pythagorean triple. I would like you to pause the video and try to solve for this problem here. In this one we have the hypotenuse, we know what that is, and we know one of the legs, and one of the legs is also unknown. So what I'd like you to do, pause the video here, and then come back and check your answer against it. And after this one is solved, you should have gotten an answer of 12 for this leg here. 12 should be your leg there. And yes, this is a Pythagorean triple because I have three positive integers. So 5, 12, and 13 is a Pythagorean triple. So that's Pythagorean theorem. And that's all there really is to it. Sometimes you're solving for a leg, sometimes you're solving for the hypotenuse. Not much more to it than that. One thing I should mention, if you're given problems that have measurements in them, so let's say these said centimeters on them, make sure your answer that you have, you put centimeters on it because labels are important. Alright, so that's Pythagorean theorem. Let's look at the converse and see what this says. So it says here, if the square of the length, let me just focus here. If the square of the length of the longest side of a triangle is equal to the sum of the two squares of the lengths of the other two sides, so if your legs squared are equal to your hypotenuse squared, then the triangle is a right triangle. So what it's saying, like I said, if a squared plus b squared is equal to c squared, then it's a right triangle and it would satisfy the Pythagorean theorem. So let's do a couple examples here. So we know everything, so we're just looking to see if the left is equivalent to the right. So again, we have a squared plus b squared equals c squared. And I'm going to use my markers to identify the hypotenuse and my legs. So the hypotenuse is always the longest side, so that's 17. And that means 8 and 15 will be my either A or B. It doesn't matter where you put them. You would get the same answer. So I'm going to put my 8 squared in plus my 15 squared. And that's going to be equal to 17 squared, or we'll at least see if it is. So we should have 64 plus 225. And then 17 squared is 289. It's going to be equal to 289. So if we add 64 and 225, we get 289. So 289 is equal to 289. That means this checks out. So yes, it is a right triangle. Do one more with you here. So let's first identify the hypotenuse, which is 25. That's the longest length. 9 and 24 would be our legs. A squared plus b squared equals c squared. Let's put in our legs. So 24 squared plus 9 squared is equal to 25 squared. 24 squared is 576 plus 81, which is 9 squared, and that is equal to, I believe, 625. Yep, 25 squared is 625. Let's add these up and see if it makes sense. So 576 plus 81 is 657, which we're saying is equal to 625, which is no. So this is not a right triangle. What I would like you to do now is pause the video, try letters C and D, see if they are right triangles by applying the Pythagorean theorem, and then play the video again and you can see whether or not you identified them correctly. Okay, you should have paused the video and now you're coming back. Letter C, I'm not going to do the work. You should have gotten no. And D is yes. If you have questions, please ask me on this part or go back and check your work to make sure you did everything correctly. So that's going to be our first foldable that covers the Pythagorean theorem as well as the converse of the Pythagorean theorem. So we're going to move on from this one now and go to our second foldable, which is more of an application of the Pythagorean theorem. And this is dealing with when we're given 2 points on a coordinate plane and we want to find the distance between those 2 points. So first and foremost, we have some directions as to how to do that, and you'll need to copy these down. So I'll read through them and then you can pause the video and copy them down and we'll get into some examples. So it says to find the distance between 2 points on the coordinate plane, 1. Draw a line connecting the points and label it C. This is the hypotenuse, so the longest side of your triangle. 2. Draw a horizontal and vertical line from each of the points. Use the coordinate plane to count the length of each segment. These are the legs. So we have 2 legs and a hypotenuse, what we need in order to apply the Pythagorean theorem, and it creates a right triangle, which is also necessary. And then 3, use the Pythagorean theorem to find the length of the hypotenuse. So exactly what we were doing in the last foldable, just have a couple more steps here to create the triangle. So go ahead and pause the video, write these down, and then we'll get into some examples. Alright, you should be back from copying those down, so let's look at example 1. Find the distance between L, -5, and point M, 1, 3. Alright, so thinking about our steps then, it says draw a line connecting the points and label it C. And if you're doing this on your own, it probably makes sense to use a straight edge. If you're doing it in Alex, it's already straight. You may have to think visually, though, as to what that connection looks like. And they said label it C, because we know that's our hypotenuse. Now what you're going to need to do is create a right triangle by creating both of the legs, and we can figure out the length of these legs. So, that didn't draw very nicely. So, let's try that again. That red does not want to work very well, so I'm going to use black here real quick. Just so we can see. Alright, that looks a little better. Not much though. And then we're going to connect this one here as well. And this, in essence, creates a right triangle, which we know the lengths of the legs. I'm going to try and darken this a little bit. Okay, so this leg, if I count the spaces on the coordinate plane, 1, 2, 3, 4, 5, 6, 7, 8, the length of this one is 8. So if I use a curly bracket, the length of that is 8. I'm going to try zooming in here too. Maybe see it a little bit better. So this here is a length of 8. And going across, so this guy here is 1, 2, 3, 4, 5, 6. So now that we know both of those legs, we can figure out what this distance is between L and M by applying the Pythagorean theorem. So we're going to go ahead and do that down here. So again, write it down. A squared plus B squared equals C squared. If we put both of our legs in there, because that's what we know, we have 6 squared plus 8 squared, and that's going to be equal to C squared, so that's the distance we're trying to find. So 6 squared is 36, 8 squared is 64. It's going to be equal to C squared. 36 plus 64 is 100. It's going to equal C squared. In order to get C by itself, we got to take the square root. So square rooty, fresh and fruity. That means C would be by itself, and that would be equal to 10. So the distance between L and M is a length of 10 units. Now if it had measurements, we would label that, but since there isn't any, we don't really need anything there. That length is 10. This actually makes a Pythagorean triple because we have 3 positive integers that satisfy a squared plus b squared equals c squared. What I would like you to do now is work through example 2 and 3 on your own, and you'll be applying the exact same strategy to both of those. So example 2 says find the distance between the point P, -4, 2, and Q, 5, -2. And example 3, find the distance between F, -4, 4, and G, -1, -3. Pause the video, try those, and come back to check your answers. Alright, so you should have done the work and checked your answers. So the length between P and Q here, you should have gotten as 9.8. I'm not going to go through all the work on them. So if you didn't get that, go back and double check what you did. And you should have rounded to the nearest tenth because that's what the directions set up here. And the last one here, you should have gotten 7.6. Like I said, if you didn't get those answers, then go back and check your work. And if you're still stuck, call me over and I will absolutely answer your question. So this is an application of the Pythagorean theorem that does show up in your AlexPy that you'll need to use. So make sure you keep both of these foldables in a safe place. Get them in your notebook. I'd probably put them on the same page or on the front and back so that you can refer to them when working with the Pythagorean theorem. And just as a quick recap, the Pythagorean theorem, or goal I can statements for this lesson: I can prove a triangle is right using the Pythagorean theorem. I can find the length of the hypotenuse of a right triangle using the Pythagorean theorem. I can find the length of a leg of a right triangle using the Pythagorean theorem, and I can find the distance between 2 points on a coordinate plane using the Pythagorean theorem. So those are the goals and lessons, or goals and I can statements, I should say, of this lesson. Hopefully after watching this seminar you feel more comfortable applying these ideas. If you're still a bit stuck, go ahead and watch the video again, or I'm always available for questions.